don't have it
I'm
not
basically
on
gonna
it.
fall
So-
anyway.
Okay, here we go now. Yeah, so again, no battle, gents. Yeah, if you're not interested, don't want to do it, or can't stay quiet or whatever, bugger off. Yeah, just being dead simple. Okay, if we want to get it done, we get it sorted. Gents, you need a chair. Grab one. Just grab one anywhere there. Just sit yourself down. Okay, relax. Okay, because it'll be easier. Okay, we got everyone else. Yeah, have you had a look at this? Good. Okay, come on. Okay, so it's just a simple little rig, a single phase installation. It doesn't look perfect, and in terms of the video and stuff as well, it's for demonstration purposes. I've checked the board to make sure it's safe, okay? So I've done dead testing on it, continuity, insulation, resistance and polarity, just to make sure everything is safe. Obviously the front is off the board at the moment, but we've got no power to us, okay? This switch fuse spur has a little neon on it that gives us a visual indication that we've got power. Okay, I'm going to turn everything off on this one, okay, and switch the sockets and all them bits off. Okay, so there's only two circuits on it. There's a radial socket circuit and we've just got a one-way lighting circuit, just to keep it dead simple. Okay, but that allows us to do all the live testing that we're going to see on. First things first, you've got a three-phased armoured cable just looping its way around onto this protection board. And the protection board has 110 volt supply, which is the yellow, and has an RCD protection. Okay, nothing connected to it. It's also got this 230 volt supply, and that one's already tripped. So do you see the way it's in the middle? If I try and reset that, it's just floppy. That's one of the examples I was saying. Flick it down to flick it back up. Okay, and when I turn it on, and I turn that isolator on, okay, it should have supply. On. Forgot to flick that switch. Too many switches, okay? But ultimately, you can see we've now got an RCD protection at that point. We're going in through the switch fuse spur. Okay, and there's the supply cable coming in. So I'm just going to turn it off and isolate it and just show you the circuits. The first thing you need to see is that white bit of armoured cable on the inside there. And what they've got is they've used the black core with that bit of green and yellow insulating tape just wrapped on it. That's going to be what's going to be our main earth. Okay? What we need to do with this board is we're going to start off by doing some testing on the external supply. So in order just to make sure that all the circuit is safe while we do them tests, we're going to carry out a safe isolation procedure. Okay, and our safe isolation procedure, okay, well, what we'll do is we'll turn the supply on. Okay, and we're going to isolate everything from that main switch on. Okay, how we do that is we literally just drop our little lock-off device in. Okay, it's in the off position. Okay, you don't have the luxury of switching these things off because that supply comes into your main switch, and what I'm showing you here is you have to be careful because the top terminals will be live. We've locked it off, put the key in there, and what we're going to do is we're going to check and make sure that we've got a live supply on the top. Okay, whenever you're checking for a live supply, always connect up to the lower voltage connection, the earth being the low voltage. We'll check between earth and line, and you can clearly see it shows 230 volts. It's gone up to the 230 volt section on that one. We'll then check between earth and neutral. What do we expect?
0.
Good stuff. And then we're going to check between line and neutral. Again, neutral is the lower voltage, so go on to it first. And then when I put line on, what do we expect?
2.5.
Good stuff. And there you go, 230 as well. That is effectively your live polarity test. So on your test sheets, has anyone got a test sheet?
No.
Just grab one from anyone that's there or whatever, okay, just grab it. Absolutely, okay, so just on that one there, what we've just done is up here there's a box and it says here about polarity, so confirm polarity. So correct supply polarity confirmed on this little box, and we're in a position now to tick that because we've just done our polarity test. Alright? We're using it as safe isolation for the other circuits, so what we're going to do is check on the bottom side of it and make sure that that isolator is doing what it's supposed to do. So again, it should be dead, so between earth and line, nothing. Between earth and neutral, nothing. And between line and neutral, nothing. This means that all our downstream circuits of the supply are isolated, but we've got a supply there. Okay, now, when you do your first live test, okay, Well, we're in a position where we're in a controlled environment, so we can actually turn the supply off, which is what we'll do. And just to be sure, I'm going to turn that isolator off as well. So I'm not doing anything on the board where there's a supply present. In the real world, you don't have the luxury of being able just to flick it off. Okay? But for this demo, we'll keep it nice and safe. In order for your first test, we're going to do external loop impedance. That is the main earth for the installation, and we're going to remove the main earth and just pull it out here. Okay? Anyone know why we disconnect the main earth to check external loop impedance?
Low resistance.
Pardon me, folks, pardon me. What we want to do is we want to check and make sure that the supply cable coming into our installation has a low enough resistance that if a fault happens, low resistance, high fault current, quick disconnection. So this test is checking to make sure that if there's a fault on our installation, that the supply cable can clear that fault. All right? So what we're going to do here is we're going to use our probes. Okay? And let's go with that. And because the earth is loose, I put a crocodile clip on that one. Again, make sure you push them things home because you want to make sure you get good readings. It's a good connection to it. Each of the probes push it home, and the croc clip and stuff. My crocodile clip's not working very well, it's not too springy. So I'm going to push it on there, and I'm going to force it with my finger and thumb, but I do not want to stand there holding it. Okay, this is going to be a live supply when we connect it up, and I don't want to be anywhere near it. There's no need for me. Line is the red, neutral's on there, and now I'm going to put the supply on. So supply goes on there, supply goes on there. Okay, and what I've not said is, I've not said how to set up the tester. So we're doing external loop impedance, which is over in the green. I've knocked the supply off before I'm changing anything on this. And then I'm going up to Z. Okay? So it tells you on the sheet here, if you're doing a ZE test, it says make sure you disconnect the main earth. There's our main earth disconnected. We connect up our earth to that one, line to line, neutral to neutral. And with my tester set up, I'm well away from anything. It picks up, there's 249 volts on there, and it just goes off and does the test. And it might take 8 or 12 seconds before it comes back. Okay, if this is a TNS system, what's the maximum value that the ZE should be?
0.8.
Good stuff, 0.8, and there we go. And you can't get much closer, 0.79. All right, now, take that one off. On real installations, you've just got to put the earth back in. You've made sure that no one can use any of the circuits, because if there's no earth, well, there's no protection for the circuit. Okay, for us in this demo, I can simply turn the supply off and turn that one off just to be absolutely safe. You can do this on the test rigs downstairs as well. Okay? But in the real world, remember, you don't get a whole lot of option to switch that power off. Okay, so we'll pop this one back in. And what's the next test we're going to do? So on that test sheet, record the value for external loop impedance setting. So we got 0.79 for that. Okay. Now, the next test is called prospective fault current. Okay? And we don't actually have to change anything. I've just reconnected the earth. And because when you're looking at prospective flow current, you want the worst case. So by connecting that and having bonding conductors and other bits of metalwork in an installation, the resistance when a fault comes will be lower. And the fault current will be higher. And you want the worst case scenario, because the fault current that we see on these tests will determine what size breakers we need to use. Okay, so what I'm going to do this time is I'm just going to connect onto the earth bar. Okay, and again, just give it a little bit of a squeeze on there to lock it on, and I'm more or less making exactly the same test. Turn the power on there, turn the power on there. Tester picks it up. I haven't had to change the dials, and I'm just doing it. Now we saw 0.79 when the earth was disconnected. Let's have a look and see if the earth is connected, if there's a lower resistance. And there you go, it's a bit lower resistance, but we're not really interested in the resistance, we want that current on the top. Can anyone see it?
313.
313, so just bear that one in mind. 313, jot it down on the side or whatever, okay? Now, I'm not going to do anything else, but I'm just going to swap that first dial from line to protective earth down to line, line to neutral. Okay? And then I'm going to put my probes back on. Make sure I get a good connection on it. And it goes off once it's detected. I've got a good supply, it goes off and it's doing the test. And it's done that really quick, but look at it, it's come in a lot lower resistance and it's come in at 441. So we had 313 amps is the prospective earth fault current, and now we just had the prospective short circuit current at 441. Which one do we record?
The 441.
The highest current, 441.
How did you do the short one again?
Okay, the short circuit one, all I did was I changed it from line protective earth to line neutral. It changes it internally in the box. It's more or less checking to see what's the fault current between them two leads, rather than the fault current between the green lead and the red lead. Okay, and again, you don't need to overcomplicate it, okay, particularly when you've only got a couple of weeks to assessment and stuff.
You answer that sheet into the exam?
You
Yes.
have to write down yourself, don't you?
Yeah. Okay, so again, it's not about training you on pure mega. It's about checking, do you have the process behind how you're going to do it, okay? And you know more than you realise, all right? Because we've more or less done half of the live testing now, okay? On the sheets, we've done live polarity, we've done ZE, and we've just done prospective fault current. Okay, is it difficult?
No.
Is it dangerous?
Yeah.
And that's the bit you just need to be aware of. You have to be safe while you're doing this thing. So we don't have loads of circuits on, we're just focused on one bit at a time, okay? So I'm going to turn the supply off, okay, and the next test we're going to do, and the only measurement test you're going to have to do for ZS, we're going to do it on the socket, okay? You can do it for the likes of lighting circuits, but you have to kind of hold on to the probes and it can be a bit awkward. And it's awkward stood here, but if you imagine if I'm on a ladder and up at a roof space or whatever that is, what they have said to us in the wiring regulations is that you can do it by calculation. So how would you get the ZS for a lighting circuit if you know that your ZE value is 0.79?
Do the loop method.
And you've done your R1 plus R2 value and that comes in at 0.111.
I don't. Yeah,
Add them together and you get 0.9 of an ohm.
Yeah.
When you record the value, it says maximum measured loop impedance. You put down 0.9 and over in the comments you say calculated. Okay?
Oh, what here?
Yeah, so in there you could just record the value and say 0.9.
And then in here you put.
Over on that
calculated.
comment you just put calculated this value. For the socket, it's much easier to do, and everything is about risk and minimizing risk, okay? So there's a socket attachment for it. Plug it in. We go back up to live to protective earth on this one. We plug it in. But now because I'm working on one of the circuits, I need to disconnect my safe isolation, okay? And again, I know my supply is off here.
Yeah.
Okay, I'm just going to do a quick check just to make sure if I'm working on the supply, nothing, nothing, and nothing. Okay, so it's better safe than sorry. Okay, and then I've got my key. And the reverse of the safe isolation procedure is just checking that the supply has actually come on. So now when I turn the supply on there and I turn it on there, I'm going to turn the main isolator on, and because I'm doing it at that socket, I'm just going to turn on that RCBO. Okay? But I'll check and make sure that I've got the supply I think I have. 230, so I'm live. Check it down here, 230 and I'm live. Check it up here, 230 and I'm live. To the neutral, nothing. Okay, I'm between line and neutral. I've got it, so I know I'm working live. Don't take it for granted, don't rush things. Okay, job done. So now I know I've got used to this thing. And again, I'm just doing a ZS test, so I turn the supply on, it picks up the voltage, and I just wait. Live testing, it's not that it's boring, I'm not even having to touch anything while the test is going on, which is safe for me. Okay, and I come back, and what do you think this one's going to be? Any predictions? If we got ZE at 0.79, well now we're getting ZS at 0.66. Does that look right?
No.
Okay, so that would be worth a comment on the side. If you do this in the assessment and you come up with a value, you just say to the assessor that looks too low. We're not going to say to you, okay, now pull it apart and try and figure out what's wrong with it and stuff. But if you record that value for ZS on your sheet and then you don't comment on it, well, it shows that you didn't see that there was something potentially wrong there.
What's that? Because that was R1 plus R2 plus the ZE, but the ZE said it was 0.79.
Yeah, ZE said 0.79, didn't it?
And that's showing lower than even the ZE on its own.
Absolutely, okay. And again, on this one, but bear in mind, when we put the earth back on, we've got the armoured cable. So I don't know whether you can see it here. There's another earthing conductor coming off the gland. And it's going up there. And that earthing conductor is going back through the metalwork here. It's going back through the earth on this one. So there's actually two paths for earth. Okay? But on this one, let's just go for it. Now, what you should do, I'm going to turn the supply off there. That was our value, 0.66 ZS, you recorded, job done.
What does it need to be? Or what's it?
Higher than.
The ZS value, if we did it by calculation, if we took our ZE value from the top of that test sheet, we've got 0.79.
Yeah.
When you did your ring main test, well, this is a radial circuit, when you did your radial test, if it came back as R1 plus R2 was 0.11, you'd expect it to be about 0.9 of an O.
Yeah, you
Okay.
okay.
Now, what you can do is, you can just recheck it, okay? And I'm not trying to make this longer than it needs to be. In the assessment, you won't need to. Make a comment and say, that doesn't make sense, it's less than the ZE value.
Would you not go to the furthest point on the socket?
Absolutely, okay.
Because
So
it's not
again, you've got to
reading that.
test that one, you've got to test that one, and you record the highest value. Good
Because
call.
it was not reading that other socket, is it?
And there you go. 0.74. And if you've got 5 sockets on the test rig, you do them 5 times and record the highest value. And which socket should give you the highest value?
The furthest one.
And how do you know the furthest one from your dead testing? The highest R1 plus R2 value.
Yeah.
Be the socket that gave you the highest value. And there you go. So that's a better result because it's 0.84, which would say that up to the main switch here, we've got 0.79. And then even though it's only a short-legged cable to there, it's giving us the R1 plus R2 value.
Yeah.
Which one of them would we record?
That one.
That one, the higher value, good stuff. So we've saved ourselves on that, well done. Okay, the only other test that we've got on here is RCD test. And I purposely disconnected this thing. And what I do is I go down to auto on RCD. Now it didn't work for the guys, so it's got a bit of an error on it. What you should do is just go on auto in 30, plug it in, press the button, and it goes through the sequence. It does half current test, then it does times 1 rated current test. Yeah, okay, we're well on track. So I'm going to do it manually. So on manual, I've gone back to half the current rated. You won't need to do it. You'll just hit auto, and you'll go through the 7 sequence of tests. Okay. So it comes back with this 48 volts when there's no supply on it. So as soon as I connect that on, and I turn the power on, it goes to 248 volts, okay? And now we need to press the test button. And I wasn't 100% sure how it worked on this thing, but I press it, and then it just gives you a little bit of a countdown to press the test button. So I press the test button, here's the test, and it comes back, and it's done greater than 2 seconds, and that's not tripped. Would we expect it to trip at half the rated current?
No.
It's a 30 milliamp RCBO, and we've just put 15
So it
milliamps
only
in.
detects up to 30 milliamps.
Absolutely.
Anything above
What
that.
used to happen with old versions of these things was some of them nuisance tripped. They weren't that accurate. So the test they brought in, they said was let's test it at half the rated current. At half the rated current, it shouldn't trip. Okay. Next one we use is these side-to-side buttons. Don't know if you can see the 0 degrees on the side, but that's just the kind of supply. And push the button, it goes to 180. With 0 degrees, the sine wave is like that. You're doing the positive half cycle first, then you do the negative half cycle. Okay? We press the button. Should it test? Should it trip? It's still on half the rated current? No trip. Okay, so nothing too amazing there. I'm just going to turn the socket off. I'm going to turn it to times 1 rated. Okay, and in actual fact, I'll do it in this one. Turn the power on. Okay. Press the test button. Will this one trip?
Should do. Yeah.
Okay, and what's happened here is, because that's a 30 milliamp RCBO, and that one's 30 milliamps. Both of them have tripped. But it tripped within 130 milliseconds. How long should it trip within for a 30 milliamp RCD or RCBL?
100.
Within 300 milliseconds. So check your on-site guide, okay? So what I'm going to do is I'm going to reset the supply, push it down, push it back up. You can see the neons come back on, and I'll reset that one. I'll do exactly the same test. I'll press the side to side button and get 180 degrees. Press test. Expect it to trip. And again, it's done exactly the same thing as trip both of them at 130 milliseconds. So no problems there. Okay, so let's reset the supply. And reset the RCBO. Then I'm going on to, I'll just turn the power off because I like to do that whenever I'm adjusting any of the dials and stuff. Put the power back on, and this time I'm on 5 times the rated current. I press test.
Try to trip quicker.
Should trip quicker, okay? And on this one, it's tripped both of them again, and it's tripped within less than 40 milliseconds, which is what the requirement is for the 18th edition. Okay? So again, go back this one, turn this one on, and now I've just done the 0 degrees, so I hit the button and I do the 180 degrees. On auto, it does all of this for you, okay? So if you're doing the test and your one's not working, you just borrow one off someone else and stick it on auto. Okay, but it's no harm to do it the long way. This is the long cut, the auto is the shortcut, yeah? Is it going to trip?
Yeah.
Okay, and it's tripped within 40 milliseconds again, so no problems there. Reset it, turn it back on, turn it on, and what's the 7th test when it comes to RCDs, RCBOs?
Press test again.
Good stuff. Just press that little test button, and again you can see it's done both of them, and that tells me that that's absolutely fine. Okay? Now, when it comes to recording your results, just over on your sheet there where it says that socket circuit, radial socket circuit, what's column 20, 1920 on that one?
This one, 19 or 20.
Yeah, so what does it say? What's the description on 19?
This is polarity.
Okay, so polarity is just a tick that we did dead testing. Okay, what's the next one?
Maximum ZS.
Maximum ZS. So we did a ZS value and we came in at, what was it, 0.84.
Yeah.
So you're going to record 0.84 on that. What's the next one?
That's it, man.
Doesn't matter, stick it
It's
in.
right.
What's the next one?
RCD disconnection time.
So you've got RCD disconnection time. What was the maximum value? We did it manually, and the maximum number we came in, it was 130 milliseconds.
What's
Okay.
going on with this pen?
Now, under normal circumstances, at times 1 racing, it'll trip in about 28 milliseconds. Okay, that's not a very accurate one that it does it this way. And then what's the last one?
RCD test button operation.
That was the 7th test where we just pressed it and that worked,
that
just
just a
put a
tick
tick.
now?
Absolutely. And then the last one is AFDD. Is there any AFDDs on these boards?
No.
Right, okay. So any queries or questions on live testing?
You
Now, I know that's quick.
For the disconnection time,
Yeah.
which one do you record? ×5?
Okay, yeah, because you'll usually put the maximum disconnection time.
What, the highest?
Highest
time?
value that you've seen across all the tests. So when you do auto, you can use the side-to-side arrow just to flick through it, and you're recording the highest value of time that you've got.
When it's what's it normally on? ×1 or something?
At times 1, you usually come in about 28 to 38 milliseconds. And then when you do ×5, it usually comes in about 18 to 28. So the ×5 is more fault current, so it trips quicker.
Yeah.
Okay,
What,
but it
you
depends on the individual unit.
You just put the biggest time on.
Yeah, absolutely. Put the biggest time in there.